Hi, my name is Mike. I'm with the Brunswick Sewer District. When most people flush their toilet, they don't think about what happens next. Once on a site, it's on a mind. Well, I'm here to tell you what happens after you flush. I'm going to take you on a trip from your flush through the Brunswick Sewer District's wastewater collection system. My friend Jason will then take you through the Brunswick Sewer District's treatment plant and finally out to the Androscoggin River. We're going to show you the wastewater treatment cycle. Begin. Being mostly on a site, your home's plumbing system remains on a mind until something goes wrong. While plumbing may appear to be a complex maze of pipes, fittings, and valves, your home's plumbing system is actually rather simple and straightforward. Clean potable water enters your home through the main water supply line. The water is metered to determine your household usage and therefore the amount of water that enters the sewer system. An average family of 4 uses approximately 175 gallons of water per day. Wastewater flows by gravity through a series of pipes in your home. Wastewater must first flow through a U-shaped trap that holds standing water and prevents sewer gases from entering your home. By state and local plumbing codes, every fixture must have a drain trap. If not used for a lengthy period of time, these traps may become dry and sewer odors can enter your home. Simply pour a little water down your drain to fill the trap and eliminate these odors. Drain pipes are connected to a vent system that bring fresh air to the drains and prevent suction that could either stop or slow the flow of wastewater. Vent pipes exit your home through one or more roof vents. It's important to ensure that these roof vents do not become clogged. Once wastewater flows through your home's internal plumbing system, it exits your house through what's called the sewer service line. A typical house service is 4 inches in diameter. Much larger service lines exist for office complexes and retail development sites. Service lines generally run perpendicular to the street until the point at which it ties into the main sewer line. Property owners are responsible for the installation, maintenance, and all related costs to the sewer service line. Sewer service lines carry the wastewater to the mainline sewer system, which is beneath the streets we travel every day. There are assorted sizes and types of sewer mains weaving their way throughout Brunswick. The main collection system consists of nearly 1,100 manholes and over 63 miles of pipe that range from 6 to 30 inches in diameter. Most wastewater flows by gravity through the collection system. In areas where the sewer would be too deep and gravity lines are not feasible, pump stations are used to lift the sewage to a higher point in the system, and wastewater continues its gravity flow towards the treatment plant. The district maintains more than 51 pump stations in the Brunswick-Topsham area. Manholes, or sanitary maintenance holes as they are known today, serve many purposes. These structures beneath our streets provide access for cleaning, video inspection, and flow data collection. Force main lines from pump stations flow into manholes where the force main is terminated, and the sewer once again flows by gravity. Manholes are spaced approximately 300 feet apart, or at any place where a sewer line needs to redirect, such as intersections. Usually manholes are concrete or brick. Some manholes in Brunswick are 23 feet deep, and one of them was dug by hand and installed brick by brick more than 100 years ago and is still in use today. Pump stations, also known as lift stations, are used to pump wastewater when gravity flow is not feasible. You will usually see them located at the bottom of hills throughout town. Pump stations often include equipment to reduce the intake of rags and large products that can clog pumps. There are 2 main types of this equipment. The first is a bar rack, which acts like a screen that catches large objects before they can reach the pump. Bar racks must be cleaned manually on a regular basis. The second is a grinder, which does just what it says. It breaks up materials before they can get to the pumps. Although this equipment reduces the amount of harmful products that reach the pumps, they do not remove them all. In fact, with more and more products claiming to be flushable, wipes and rags are becoming quite a problem. Other interesting devices at pump stations include variable frequency drives, known as VFDs, and programmable logic controls, known as PLCs. A PLC is used to monitor flow, well levels, generate alarms, and control pumps. They control pump rates and times to ensure that the flow to the treatment plant is consistent. The PLC, in conjunction with a VFD, starts and stops pumps or adjusts the speed of the pump automatically depending on the rate of incoming flow. These devices greatly reduce the power consumption at pump stations by up to 50%. In most cases, it is more cost-effective to run a pump for 20 hours straight than to have it turn on and off 10 times a day. The Brunswick Sewer District has a couple mainline interceptor pipes. One is a 30-inch diameter gravity line that runs from the Bowdoin College area to the treatment plant. Another, known as the Cook's Corner Interceptor, is a 21-inch diameter gravity line that supplies service to Cook's Corner in the Bath Road areas. This major trunk line collects waste from the edges of West Bath, along Bath Road, the Cook's Corner area, and Brunswick Landing. The interceptor delivers the wastewater directly to the treatment plant. Now that you have seen the collection system process, I will hand you off to my friend Jason, who will take you through the treatment plant.
Hi, I'm Jason. Now that you know about the sewer collection system, I'm going to take you on a tour of the Brunswick Sewer District wastewater treatment plant. The treatment plant replicates what happens in nature, but it speeds up the process. Are you ready for your learning ride? Buckle up and hang on. As you know by now, the Brunswick Sewer District wastewater treatment plant receives wastewater flows from Brunswick and Topsham. The plant also receives septic waste from surrounding communities. There is a good chance that we treat your septic waste even if you are not connected to the BSD collection system. Upon entering the treatment plant and prior to any treatment, wastewater flows through a metering device. This device tells how much wastewater comes into the treatment plant each day. The BSD plant is designed to treat 3.85 mgd, or a million gallons per day, but can treat up to 11.5 mgd for short durations during storm events. Current flow averages about 2 mgd. After being metered, wastewater enters the headworks for the first stage of treatment, which is a mechanical process. Septic waste that has been collected and trucked in from homes in Brunswick and the surrounding communities is introduced into the wastewater flow at the headworks. The wastewater then enters a grit chamber, where air is added into the wastewater to freshen up the water and begin treatment. The air helps grit and large solids settle out of the waste stream. Grit that settles in the grit chamber is removed with a clamshell bucket hoist, and the grit is disposed of at the Brunswick landfill. The clamshell hoist was constructed in 1966 and is still in use today. After the waste stream exits the grit chamber, the water passes through a diminutor. A diminutor is a device that grinds rags and breaks up solids. Although diminutors do a good job breaking up solids, even some small plastic, they cannot break up rocks and hard hats. Yes, we have had to remove a hard hat. Please don't send hard hats and other plastic toys down the waste stream. Diminutors do not remove rags, so the fibers reconnect downstream and create additional problems. Flushing rags and baby wipes is a severe problem that drives up the cost of treatment. After grit has settled out and the wastewater has passed through the diminutors, wastewater flows out of the headworks and enters the primary clarifiers, where the physical treatment process begins. There are 3 primary clarifiers buried under the ground. They are each 105 feet long by 20 feet wide and 8.5 feet deep, and hold approximately 130,000 gallons. The clarifiers act like large septic tanks. Grease floats to the surface while heavy material called sludge settles to the bottom. The grease is collected and manually removed on a regular basis, which is usually every 2 weeks. The sludge that settles to the bottom is pumped out of the primary clarifiers to a holding tank, where the material waits for solids processing. At this point, the sludge is a dirty liquid that is approximately 3% solid. Primary treatment removes nearly 2/3 of the harmful material in the wastewater. The primary treated, cleaner wastewater flows from the primary clarifiers into the primary effluent wet well, which is essentially a very large pump station. Wastewater is collected in the wet well and then pumped through a 30-inch diameter force main to the top of the trickling filters. The district uses one 60 horsepower pump and one 30 horsepower pump to handle average flow and overcome the head pressure for pumping to the top of the 46-foot tall trickling filters. 2 more 60 horsepower pumps can be put online to handle high flow situations. Now that the wastewater has been pumped to the trickling filters, the mechanical and physical process of primary treatment are concluded. The next step is biological treatment, which is known as the secondary treatment process. The wastewater that is pumped from the primary effluent wet well to the top of the 2 trickling filters is spread evenly across the surface of the filters through revolving pipes known as distribution arms. These arms have holes known as ports. The trickling filters are 86 feet in diameter and about 46 feet tall. You can see these structures as you drive along Route 1 between Cook's Corner and Main Street. The biological treatment process happens when microbes consume organic matter in wastewater and convert it to carbon dioxide, water, and energy for their own growth and reproduction. The microbes grow on a plastic cross-flow type media, which looks like a honeycomb. The media in each filter is 22 feet deep. The cross-flow design enables more biological treatment to be accomplished in a smaller space because of the increased surface area. The surface area in each filter is 3,830,000 square feet, the equivalent of 80 football fields. More area means more room for microbes to grow. The slimy growth on the trickling filter media is called a zooglial mass. It is where the microbes such as nematodes, stalked ciliates, and rotifers live and break down the organic chemical bonds in the waste. When the biological treatment in the trickling filters is complete, the microbes have eaten their fill. They are fat, dumb, and happy. The microbes will die from lack of oxygen. They fall off of the trickling filter media and exit the bottom of the filter as a solid called humus, also known as secondary sludge. Flow coming from the two trickling filters is split by the distribution box and sent to two secondary clarifiers. A variable amount of flow is also sent back to the primary effluent wet well to recirculate the water through the trickling filters. On average, every gallon of wastewater that comes into the treatment plant is pumped 2 times through the trickling filters. This recirculation allows efficient growth of microbes by ensuring that the trickling filters get a constant wetting rate and that the microbes are always being fed. Then it's off to the secondary clarifiers, which are 3 times the size of the primary clarifiers. They are round while the primary clarifiers are rectangular. The secondary clarifiers are 80 feet in diameter and 12 feet in depth. They hold 450,000 gallons and have a detention time of 1 to 2 hours. The humus is collected at the bottom of the secondary clarifier and pumped back to the headwork so it can be run through the primary process again. The primary sludge and humus mix and co-settle in the primary clarifiers. Once the wastewater passes through the secondary clarifiers, the biological secondary treatment process is complete. Treatment is almost done.
The final phase of wastewater treatment is disinfection. Disinfection happens in the chlorine contact tank, where 15% sodium hypochlorite, which is a bleach that is 3 times stronger than household bleach, is used to disinfect the wastewater before it is discharged into the Androscoggin River. The bleach solution is added at the beginning of the contact tank and is mostly depleted by the time the flow reaches the end of the contact tank. The contact tank has a serpentine flow to allow for a detention time of 1 to 2 hours. Once the wastewater is treated and disinfected, it flows through a 30-inch diameter concrete pipe under US Route 1 to the outfall at the Androscoggin River. The river water dilutes the treated wastewater as it rushes down the river. Nearly 1 billion gallons per year of wastewater is treated and discharged from the treatment plant to the Androscoggin. The outfall is located in a tidal section of the river. It is submerged half of the time and visible the other half. Periodic maintenance is required to ensure the outfall does not erode due to the tidal action and flows of the river. Wastewater treatment is complete. The wastewater treatment plant was constructed as the first primary treatment plant on the Androscoggin River in 1967. In 1991, the treatment plant was upgraded to include secondary treatment and continues to improve the water quality of the Androscoggin River. The Brunswick Sewer District Treatment and Collection System and crew have won multiple awards for their proactive, efficient treatment process. The community should be proud of its award-winning system.